Hello viewers, good morning. Welcome to Quick Coder. My name is Tulasi. Today's topic is bubble sort in Java. So let's get started. Okay, so sorting technique. So bubble sort is some type of sorting technique which always repeatedly uh, swaps the adjacent elements, okay, and brings the largest element at the end. Okay, I want to explain this problem with some example. Okay, let's get started now. So first of all, take this array. Okay, suppose you take this array. What will happen here is first of all you compare these two elements, 5 and 9. So which is largest? 9 is largest, 5 is smaller. So okay, it's small and it's big. It's in some ascending order. So leave it. Again, come to these two. Come to these two. So I want to explain it in a detailed way. Okay, so go with this. This is the first iteration. So what you will do in first iteration, first comparison. So you will compare these two, 5 and 9. Okay, 5 and 9 is okay. So this is a small number, this is big number. So as it is, 5, 9, 8, 2, 1. Okay, in first, uh, in first iteration, second comparison. Okay, 9 and 8. For suppose if you compare 9 and 8, 9 is big, 8 is small. So let's swap it. 5, 8, 9, 2, 1. And again, in the third comparison, first traverse, third comparison, compare these two elements, 9 and 2. So 9 is big, 2 small. Again, swapping occurs. 2, 9, 1. And again, in first traverse, fourth comparison, compare these two, 9 is big, 1 is small. So reverse that. Okay. So this comparison is over. If you see here, the last element, okay, the last element is the largest element among this 5, 9, 8, 2, 1. Okay, now let's do the second traversal now. Okay, let's the second one is something like 5, 8, 2, 1, 9. Okay, 9 is already at the last. So compare now. In the second traverse, first comparison, compare these two elements. If you compare these two elements, this is already small, this is big. Okay, so as it is 5, 8, 2, 1, 9. Okay, and again in second traverse, second comparison, compare these two. 8 is big, 2 is small. Okay, swap it. Now again, in second traverse, third comparison, compare these two. As 8 is big, 1 is small, you have to swap these two elements. You will get, okay, you will get 5, 2, 1, 8, 9. Okay, this is already sorted. We don't need to compare this one. Okay, we will get 5, 2, 1, 8. And here one thing you have to understand is the last one you got 8, 9 as sorted elements. Okay, and now let's go through the third iteration now. Okay, take this 5, 2, 1, 8, 9. Okay, already these two are sorted. In third traverse, first comparison, compare these two. No, 5 is big, 2 is small. So swap them. Okay, and again in third traverse, second comparison, compare these two. 5 is big, 1 is small. So swap it. If you see 5, 8, 9 are already in ascending order now. Now go with the fourth iteration, fourth traversal. Okay, so in fourth traversal, what you can observe is as 2, 1, 5, 8, 9 are already in ascending order. In fourth traversal, first comparison, compare these two. 2 is big, 1 is small. So 1, swap them, 5, 8, 9. Okay, this is in ascending order. So if you come to some certain points, you can observe some certain points here. The first point is how many traversals we require. For suppose if we have n traversal, if we have n elements in an array, then we require only n minus 1 traversals. Okay, See here, 1, 2, 3, 4. We have 5 elements total. So here my n is 5 and my total traversal is 5 minus 1, that is 4. Okay. For each traversal, how many times you have to traverse? For example, this is the first traversal. First traversal, how many times you traversed? Total 5 minus 1. That is 4. Okay. If you see here, how many times you traverse? 3 times. Means total elements 5 minus. See, I have to say something here because this is the first iteration. Okay. For example, in programming language, if you think this is the 0th iteration, this is the first iteration, this is the second iteration, and this is the third iteration because it is started from 0. So I can say take these iterations as I values. Okay. Take these iterations as I values. 5 minus I minus 1. For example, if you see 5 minus I is 0 minus 1, that is 4. If you see here 5 minus, what is my I? 1 minus 1, that is 3. And if you see here 5 minus 2 minus 1, that is 2. 2. If you see here 5 minus something third iteration, 3 minus 1, that is only 1. Okay, like this you can conclude it very it's very simple algorithm. Okay, here it traversal 4 times, 3 times, okay, 2 times, and only 1 times. Okay, you can simply do this with programming also. Okay, I want to explain this with programming also. So let's get started with some programming. Okay friends, now I started coding. I have my array in this bubble sort function, and I have n. N is total number of elements in this array. Okay, let's start coding now. Okay, so first of all I have to run my loop up to for int I is equal to 0, I less than only up to n minus 1. Okay, n minus 1 and I plus plus. And my second loop will be, I already explained, for int j is equal to 0. Okay, and my j less than n minus I minus 1, 1, and j plus plus. Okay, now what I have to do, when the swapping requires only when the, if we take two elements, for example, if array of I, if array of I is greater than array of j, then only we require some swapping here. Okay, like in temp is equal to array dot I. Oh, sorry. If sorry, I wrote something here wrong because I am comparing only the j with j, and j plus 1. Okay, and array of here array of j. Okay, and here j. So don't worry, I will also explain the what I explained before. I also explain through this code. Okay, don't worry. Is equal to array of j plus 1 and array of j plus 1 is equal to m. Okay, so that's it. That's it about this code. So let's run first of all. Is there any errors? Okay, this one is sorted. So let's submit. Yeah, correct answer. Okay, let's analyze this code. Give me some time. Okay, so let's analyze the code. So first of all, here my I runs from 0 to n minus 1. Means my will be 0, 1, 2, 3. N minus 1 means here 4. So I less than 4 means up to 3. So 0, 1, 2, 3. Okay. My j will be, so first of all, if I choose my I as 0, okay, so first of all, I will choose my I as 0 and my j will be 0 to 0 to n minus I minus 1 means 5 minus 0 minus 1, that is 4, means 0 to 4 means my j will be 0, 1, 2, 3. So let's take first I as 0 and j as 0. Okay, j as 0. Now I will take my array 5, 9, 8, 2, 1, and this array is indexed as 5, 0, 1, 2, 3, 4. Okay, what I will do is array of j and array of j plus 1. J plus 1. Okay, means array of j means fifth, array of j means 5, and array of j plus 1 means here array of j is greater than array of j plus 1. I'm comparing you. So what is my array of j means 0 greater than array of 0 plus 1 means 1. Okay, array of 0 means 5. Is 5 greater than 9? No. So okay, this one over, j is over. Now my j will be 0, 1, 2, 3, no, up to 0, 1, 2, 3. Okay, 0 is over. So let's check with 1. Okay, let's take j as 1. Again now, array of j means 1, j plus 1 means 2. Is array of 1 means 9 greater than 8? Yes, 9 greater than 8. So swapping occurs. Means here 8 will be replaced, 9 will be replaced. Okay, 1 is over. So let's take 2. Array of 2 is greater than array of 3. So array of 2 means 9 is greater than 2. Yes, true. Again swapping occurs. Means here there will be 2 and here there will be 9. And again with 2 over. So let's go with j as 3. Let's take array of 3 greater than array of 4. Okay, array of 3 means 9 and array of 4 means 1. Is 9 greater than 1? Yes. So swapping occurs. So in place of 9 we will get 1 and here we will get 9. Okay, our after first iteration my total array will be 5, 8, 2, 1 and 9. Okay, so let's go with the second iteration. So give me 1 minute, I will erase this. So as I is 0, so 0 is completed. So now I am taking I as 1. Okay, my j will be 0 to 5 minus 1 minus 1 means 0 to 3. So first let me take j as 0. Okay, so I will get here array of 0 means 5 and array of 0 plus 1 means 8. Is 5 is greater than 8? No. Okay, so let's take with 1. So array of 1 means 8 and array of 1 plus 1. Array of 2 means 2. Okay, is it true? Yes, it is true. So I will swap 8 with 2 and 2 with 8. So here 2 and here will be 8. Now I will take 2 with 2. Okay, array of 2 means 8 and array of 2 plus 1 means 1. Is 8 is greater than 1? Yes, it's true. So again, the swapping occurs. Okay, here I will get 1 and here I will get 8. Okay, so that's it about this. And now I'm taking my I as 2. So now my I will be 2. So what is my j? J is 0 to 5 minus I means 2 minus 1 means 0 to 2 means my j will be 0 comma 1. So first let's take j as 0. So what is my array of j? 5. Is 5 greater than array of j plus 0? Array of 0 plus 1 means 1. So array of 1 means 2. Is 5 greater than 2? Yes, it's true. So what will happen now? So first of all I will swap. Okay, 2 here, 5 here. And again, I will go with j as 1. What is array of j? 5. Is 5 greater than array of j plus array of 1 plus 1? That is 2. Yes. So again, the swapping occurs. Here 1 and here 5. So that's it. So now what I will do is, okay, so we are done with, sorry. Okay, we are done with 2. So let's take I as 3 now. Okay, if my I is 3, my j will be 0 to 5 minus 3 minus 1. That is 0 to, 0 to 1. Means my j will be only 0. So let's take if my j is 0, what is array of 0? 2. Is 2 greater than array of 0 plus 1? That is array of 1 means 1. Yes, it's true. So what I will do, I will swap 2 and 1. Okay. Okay. I will swap 2 and 1 now. Here 1 and here 2. Okay, so that's it. So we are done with 3 also. So I loop over, j loop over. So it's come out of this and my array will be like this. 1, 2, 5, 8, 9. It's sorted. So that's it about this bubble sort. So what do you think about this time complexity? Here we are exactly running this up to n minus 1. Okay. Okay, let's think about what is the time complexity of this algorithm. Okay, this loop runs up to n minus 1 times, and this loop run up to n minus I minus 1, and this is of 1. Okay, so what is the time complexity? Of n minus 1 into of n minus I minus 1, that is, and here we are running up to row of 1. Okay, this is something like constant. Okay, so this is something like constant, and here it is running n minus 1 times, it is running n minus I minus 1 time. So n into n square, n into minus I and I, and n into minus 1 minus n, and here minus n, and here plus I and plus 1. Okay, n square minus ni and minus 2n and plus I plus 1. Okay, and plus, sorry, this is of into c1. So if you do into with c1, so we will get cn square minus cn I minus c into 2n. So like that. So what is the fastest growing term among these all the terms? Exactly cn square. So if you take cn square, so what is the two steps I already discussed in time complexity videos. So first of all, you have to find the fastest growing term. Okay, fastest growing term among these all. And the next step is remove the coefficient. Remove the coefficient. If you do the same thing, the fastest growing term is cn square. If you remove the coefficient, you will get only over n square. So the time complexity is O of n square. So that's it about this video. I already explained how the bubble sort works. Okay, I also explained by writing code and by tracing out the code with some example, and I also explained the time complexity of this code. Thank you, friends. Thank you for watching this video. The coming up topic is selection sort in Java. So let's wait for this. Thank you.